Hello, and welcome to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I'd like to introduce KYZEN's own John Norton.
Okay, thanks for the introduction, William. Hello, everybody. Thank you for joining in on Tech to Tech. Today, we're going to be discussing handheld ultrasonic generating systems that are used to clean your stencils. First, we'll talk about a couple of things. Why be concerned with stencil cleaning at all? Well, what's happening? There's things in the industry that are changing. One, the type of paste that's being used is changing. It's getting smaller and smaller, which means more and more metal. The apertures are also getting smaller. And you want to make sure that you that you have good chemistry to dissolve these out of the apertures. And one of the main reasons in that is out of your SMT line, typically 60 to 70% of your defects are coming from the paste system. Traditional IPAs, they do not dissolve some of the newer pastes. Some of the newer pastes have other properties that are in them that do not dissolve traditionally like IPA would do it. And as the solder paste dries, the deposits inside the aperture create the defects from the wall. Dirty apertures can create defects we talked about. They clog their dirty apertures and they cause bridging. They cause insufficient solder. They cause solder balls and excessive solder. So keeping them clean is very important. Let's look at the mechanics of printing. It's pretty straightforward. The PCB comes down, or the stencil goes down onto the PCB. The paste is then applied through the aperture onto the PCB. But in the second image that you see here, where you see the paste bending, that's called snap-off. And this is where it actually sticks to the stencil and sticks to the sides of the aperture. So as they're separating, the wetting forces between the stencil and the solder paste snap, and that creates the defects of building up on the apertures. And as that aperture builds up and begins to dry, it can also stick to the bottom of the stencil and put paste in areas you don't want it. Choosing the right chemistry. So there's all kinds of different chemistries out there, and there's all kinds of different solder pastes out there. So you want to get one that will break down the paste itself, and it will turn it into like a silt. So as you look across this image here, those are all different pastes, only using IPA with 100% IPA. And you can see if you do not have solvency in there and they do not break down, they will remain solid. They will not dissolve. Also, when picking it out, you want to look and make sure that there's no bad reactions with the paste or the effects that affects the paste velocity. The process compatibility is also important. Whether the material dries evenly, whether it has no adverse effects on any portion of the stencil, any type of coatings that are on there. And obviously there's health and safety involved. Is it non-flammable? Is it semi-flammable? Is it low flash point flammability? And odor. This is what proper solvency would look like. You can see the paste on the left. See how it's turned to a silt? That's using a proper chemistry. When you go onto the image on the right, that's IPA. It won't break it down. IPA will break down some, but it's as the pastes are evolving, that's where we're running into this issue. So there's all different types of ways to clean a stencil. You can wipe it, you can put it in spray and air, you can put it in spray and immersion, you can put it in an ultrasonic tank. There's all different types that are out there. What we're going to focus on here is the handheld units. So these handheld units, they're very simple, they're cost-effective, they're portable. They consist of a single head or multi-head, and those heads are like that black puck that you see down there. The multi-head is on the right-hand image. That's got 4 heads on it. And what the ultrasonics do is they break down the paste by using the chemistry. So it's basically pretty simple. They're usually on a fixed frequency. They don't have adjustable frequencies for the most part. Unit comes with a cable, a generator, a puck, and usually a foot switch. Some of the generator manufacturers out there also make a table, which is an important portion of using this correctly. Because what you're going to be doing, the ultrasonics, you're going to place the stencil onto an absorbent cloth, and that cloth or towelette, that cloth is actually what's wicking out the chemistry as the ultrasonics and the chemistry breaks down the paste. It wicks out onto that unit, so that's an important part of it. Some of the benefits: it can clean small apertures. It's a very cost-effective approach. It's better cleaning than just plain wipes, whether you use an IPA or not. It's easy and it's easily portable. It's very simple. There's no exposure to the screen, the emulsions of the screen on the side, which can happen when you submerge a stencil in a cleaner. And it can also be used sometimes with your consolidated waste stream. So when you're done with that towelette, you're done with it. If your hazardous waste people are allowing wipes in the pickup, you can place it in there. Unlike a stencil cleaner where you have a liquid that you're going to have to exchange from the tank. There are some disadvantages, though. You're relying manually on an operator again. So how well the chemistry is applied, how the use, the movement of the puck across the apertures is being used. So it is a manual one. You can have some mechanical interface on the stencil surface, unlike spray in air and spray under immersion. So you physically can have the puck come in contact with the stencil. And that can also affect, the stencil life. Some of the other deficiencies, the ultrasonic energy, mechanical energy, that's both the operator and the ultrasonic itself, can have an effect on some of the coatings, like a nanocoat. The ultrasonic energy can affect aperture edges. It can break them down over time. This would put noise on the floor in the printing area. And it's open cleaning, so you can have odors if you don't pick the right chemistry. So let's talk about the proper use. So the way that this is used is you wipe off your excessive paste from the top and the bottom of the stencil itself. You place an absorbent material down, and then you place the aperture, the areas to be cleaned over that, and you let it rest on there. And again, what's going to happen is as the chemistry breaks it down and turns it into that silt that you saw, it's actually going to wick it out. So it's going to pull it down into that absorbent material. And the more absorbent, the better. It'll help and assist in the wicking. Then apply the chemistry to the area and take the puck and put it in a handheld rotary area. Do not push down on it. So don't push down hard. You want the sonics and the chemistry to do all the work. And then the, the absorbent towelette will pull all that out of there. Gently pass it over the apertures, typically in a circular motion. The energy is going to assist in encapsulating the chemistry in the flux and the paste, and it's going to wick out onto the unit. Some chemistries would require rinsing also, some don't. Frequently asked questions on this topic. People ask what type of frequency is the generator. Typically they're fixed, like I said, that there's 40 hertz, there's 44 hertz, I've seen a number, but they're all very close within that same band. Do you need the absorbent towel under the stencil? Yes, you do. That's a very important part of it. That is the wicking action that's actually going to clean it out. So the chemistry is going to be the carrier to break down the paste. The ultrasonics are going to be what's going to break down that also and turn it into that silt-like material that we talked about, and it's going to wick it out. Another question people ask is, what's the best type of absorbent towelette to use? So typically what that is a hydro-entangled single fiber polymer. It's a material that's synthetic. It doesn't contain any glue or binders that can get stuck into the apertures. So it's not all the towelettes are the same, is the point. Another question, can it affect nanocoatings? Yes, of course, you can have an effect on nanocoatings. So can IPA or any type of mechanical movement across the surface of that. Okay. So thank you for joining today. Appreciate it. Hope this was helpful for you, and have a great day. Take care.
Thanks, John. And thank you guys for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.